Hi and welcome back for part 2 on chapter 2.1, indices and logs. Again, I'm going to make a lot of assumptions that you have seen the log laws from last year, that you understand them relatively well. If you don't understand them, if you don't know them, like either ask me or ask someone else about them, because you do need to know them. So I'm just like in year 11 we sort of learn the laws. In year 12 we sort of apply them a lot more, and we do a lot of manipulating in equations and stuff. So my assumption is that you're pretty good at this kind of stuff. Again, just a recap of some of the log laws that you'll remember or you'll see. A log to the base of a of 1 is always 0. Log to base a of a, so if those two numbers are the same, the base and that number in there is the same, then it always equals 1. Log a of 0 is undefined. These can all be, all the log laws can be found by exponentials actually, manipulating exponentials to become logs. They're sort of related, in fact they're the inverse of each other. We'll get onto that later. Now you can't have, x cannot be less than 0 for log a of anything, so you can't get log a of -1 or log a of -5 or anything like that. It always has to be greater than 0. Now here are the laws, I guess, that we'll sort of use a little bit more. When you add two logs together, they must be of the same base. That means that you can multiply the bits inside the log. And we can go reverse actually. We can split this one up into two different parts. When you subtract logs, the two logs, they must be of the same base again. And there mustn't also, with these, you can't have a number out the front. So for example, you cannot do anything you can't just quickly add these two together. You must do something first. Notice how this one doesn't have a 2 at the front and this one does. You can't do anything with that one. You have to actually manipulate this one or rearrange this one in order to do something. We can do something, and I might just leave that there and come back to it. So when you subtract the two logs, that means that you divide the two parts inside the log. Now with this one here, we can actually rearrange a log so that the power actually comes out the front. So the opposite of what I've got here, I guess. That one, I can use this rule here, rule number 7, to make this one into log a of m to the power of 2. And then once I've got that, then I can come back to this question here, and then I can I can divide the m squared by n. I'm just going to tidy this up a little bit. So now that would become log a of m squared over n. Okay, so you can drag the power down the front, or you can move the power up the top. That one's probably the one that I see the most of in exams and things. Although I guess the other ones are there too. Now rule number 8, to be honest, we don't really look at rule number 8 anymore because we've got our calculators. The reason that this was really good was because the old calculator, back in the dark ages, they could only do log to the power of 10, and log to the power of e. I'll talk about e a little bit later. So what they would need to do is turn log to the base, say 2 of 5. They wouldn't know how to do that, so they'd have to make it log 10 log 10 or log e of 5 divided by log 10 or log e of 2, because then they could actually be able to do it on the calculator. We don't need that anymore. There have been a couple of questions that I've seen that kind of rely to utilize that rule, but I haven't seen a lot of them. What we'll do is we'll just put it on the shelf for the moment, and then later on I'll show you that question so that you can have a look at it as well. Okay, so I'll just rub out this stuff here because it's not all that necessary. Now another thing that I would like you to know for logs is this thing here. It's probably more relevant as we get onto equations, but you can always turn a log, like an indice, into a log. So the old switcheroo. You can go from left to right or from right to left to make it. Sometimes it's easier when it looks like a log, and sometimes it's easier when it looks like an indice. But we can do both of those things. Okay, now I just want to talk a little bit about Euler's number. Now again, I'm not going to go into too much of the details. I'm happy to talk you through how they got this number and why they use it and all that sort of stuff. But Euler's number is essentially, it's kind of like a number like pi. Pi being 3.14159, and it keeps going forever and ever and ever. Euler's number sort of does the same sort of thing. We approximate it to 2.71823. Sorry, 3. It doesn't really matter too much what that is, but it's basically a number that we use. It's the natural number. We like to use it for exponentials and logs. So sometimes you'll see log e, and sometimes you'll see e to the power of. And I guess I'll go through where you'll come across that now. We use it in both exponentials and logarithms, but most commonly we keep it in its exact form, e. Okay, now use it on your calculator. There's a couple of ways that you can get e. If you're on one of the newer style calculators, it's this button over here. That's e to the power of, and above it you'll see ln. I'll talk about ln in just a second. And then on the grey calculator, if you've got one of those, it's got e to the power of x is there, and ln is on the top. I don't want you to manually type in the letter E, because I have seen it work, but sometimes I've seen it come unstuck. So don't find this little E up here or this E down here, and don't use that, because I've seen it come unstuck a couple of times. So now this ln thing, ln just means the natural log. So ln means log E of something. So for example, log E of 5 is the same as ln of 5. Okay, that's the natural log. It's exactly the same thing. Another one there. So when we're finding log E, we can also type natural log of 8. Okay, so that's log E and also logs as well. And I hope that makes a little bit of sense. If you need any more help with it, please ask me. The next video I'll talk about functional equations for exponentials and logs. So thanks.